Hi, everybody. Welcome to section 5.4, the definite integral and area. So at the end of today's lesson, you'll be able to relate area to the definite integral and interpret the meaning of a definite integral using the concept of accumulation. So let's go ahead and look at some warm-up problems. So let's go ahead and skip number one. You can see I crossed it out there. But look at number two. So what does D equals R times T mean to you? So let's draw back to our previous education. And what D equals R times T means is distance equals rate times time. Okay, so let's go ahead and try out an example using this review of distance equals rate times time. So how far does a person travel if he or she travels at a constant rate for 5 hours? So we have a rate and times time. We want to find how far a person traveled. So our distance would be 15 miles an hour times 5 hours, and that's just 250 miles. Okay, so expanding this idea of distance equaling rate times time, let's look at this figure below. Here we have a constant velocity function, v of t, meaning velocity function, which is also a rate. Okay. And we have our horizontal axis being in terms of time. So if we read through this question, what geometric quantity relating to the figure below represents the distance traveled by the person over 5 hours as described in the previous problem? So what geometric quantity? So what that means is I want to find the distance traveled over the 5 hours. So underneath this velocity function, I want to find the distance traveled in 5 hours. So what that means is I'm trying to find this shaded region here below the function, above the axis until 5 hours. So what geometric quantity looks like this? Well, to me, this looks like a rectangle. It's not a square because the sides are not the same. This is 5 hours and this is 50. So it's a rectangle. So this rectangle, I want to find the distance traveled. And what that means is I need to find the area of this purple portion below. So that means the area of a rectangle, and if you recall, it's length times width. Okay, so if I look at my figure to the left here, the length of this rectangle is going to be that 50 miles an hour. That's how long, or that's the height of it. So this would be 50, and the width of this rectangle is going to be 5. So the area of this rectangle is going to be 50 times 5, which is 250, which is the same thing we got above in just our short word problem, but we got the same exact answer when it's a figure on a graph. So finding the area helped us figure out the total distance traveled. If it's a constant velocity over a certain amount of time. But what if the velocity function is not constant. As we look at the graph here, it goes up, down, and etc. It's not a perfect square like we have, sorry, not a perfect rectangle as we have above. It's not a clean geometric shape. So what do we do if the velocity is not constant? So in this section, we're going to figure out a way to find the area of a, we're going to find the area underneath a function on a graph. Okay, so that's it for this video. In the next video, we'll get into how to find that area, but that's a brief introduction, and I'll see you next time. Thank you. Bye.